Thank you very much there, Alain. So now we're going to reset the scene from various angles, and we're now going to move on to our first panel. And that's going to look at the new designs that we'll need to make all of this possible. So I'd now like to welcome on stage, please, Rachel Reschler, who is our Certification Director at EASA, and all the panelists, if you could also now come up at this stage. Thank you very much.
Ça va? Oui. Nice to see you.
Phil sitting there.
Va bien? Ouais, toi aussi. Ça va, comme ça? Hey, Sébastien.
So, good afternoon, everybody. And it's a pleasure to moderate this panel. A few words of introduction. Green technology readiness is expected by 2030, 2035. Around these dates, and the sooner the better. This panel is all about getting to know where we are with respect to propulsion and aircraft, green new technologies, and the questions that I have on my mind, and for which I hope we will get some of the answers, are what is in the pipeline, how green will it really be, and what are the maturity levels of what is in the pipeline, what are the main challenges, safety challenges, sustainability challenges, but maybe also organizational challenges. And last but not least, also I have a question on, and we discussed that previously, how can EASA best help? So what do you need from EASA? I'm very pleased to have on this panel a very good representation of European industry and also of a public-private partnership program with Clean Aviation. A good mix of well-established players and also new entrants, which are all very active in developing new green technologies. So let's start. I will start with Rolls-Royce. Adam Newman, welcome to the conference and to this panel. Adam, you have joined Rolls-Royce in 2005 as a graduate trainee, and you have moved up in the organization. In 2015, you've been promoted Assistant Chief Design Engineer for the Trent XYB program, so still a very conventional, although top of the edge, but conventional propulsion system. And in 2017, you moved on by being appointed Chief Design Engineer of Hybrid Electric Aerospace Propulsion. And further down the road, in 2021, you were promoted to Chief Project Engineer for the hydrogen propulsion demonstration. So here, a change of technology. So my question to you, Adam, is where is Rolls-Royce going to? Is Rolls-Royce going electric or hydrogen, or maybe both? And what steps are you taking to go there?
Okay, well, thank you. So firstly, thank you very much for inviting me to be part of this panel, and very looking forward to engaging with you all over the next couple of days. I guess as chief engineer for the hydrogen demonstrator, I feel like I've probably got one of the best jobs an engineer could have, really trying to solve genuine technical problems that can make the world better. So in the single slide I'm going to present today, I'm going to really talk about Rolls-Royce's strategy to net zero and our roadmap. Our world is changing. There are more people. Those people demand more power. As a company, we continue to believe that aviation is a fundamental force for the good. But we cannot ignore the growing climate challenge and our impact that our operations have upon it. Rolls-Royce's ambition is to lead the transition to net zero carbon in some of the hardest parts of the global economy to decarbonize, with quite rightly some of the highest safety standards that are expected of us. We don't believe there's a single solution to the problem. We think it's going to be a really complex future. And we've pledged that by 2050, we will be in a position to support all of our customers in their net zero operations. And 20 years earlier, by 2030, we want to have our own operations at net zero. We believe that technology has a significant part to play in this future journey, but it's going to be a hard road ahead, and it's going to take a lot of focus for a number of years to achieve that. So really, our journey to net zero starts on the left-hand side of the picture above me, and that's around efficiency. Whatever fuel we use in the future, if we use less of it, that's better. Over Rolls-Royce's history, we have great experience at continuing to improve our products. And every one of our civil aviation products today exceeds the regulatory requirements of noise and emissions. And over 98% of our existing engines can be recycled at the end of their life. But we've not stopped there, and we have a program of continuous improvement to improve our in-service fleet and improve our customers' operations. But moving on from that, we are looking at evolutionary steps like the UltraFan, which is our latest product, has a 140-inch fan diameter, which, to give you an idea of just how big that is, a London Underground train could pass through the fan. And with that 140-inch fan and the 100,000 horsepower gearbox, that engine promises to be 25% more efficient than our first-generation Trent. Moving on from efficiency, we look at new fuels. Already today, our new products are passed off with a blend of sustainable aviation fuel, and by the end of this year, we want to show that all of our civil aviation and business aviation engines can operate on anything from kerosene through to 100% sustainable aviation fuel, and we're on track to meet that objective. Moving on from efficiency and fuels really brings us into the alternative technologies and really the focus of where we are today. And those technologies range from increasing hybridization of our engines and the increase of electrification through to fully electric propulsion systems, and then through to the use of hydrogen, either combustion within a gas turbine or part of a fuel cell with our partnership with Hyundai. You'll have seen recently we've made some great achievements already in our pursuit of hydrogen. The picture you saw in the previous slide above my name is the world's first aero engine to run on 100% green hydrogen. And that was a challenge we achieved in less than 9 months last year. You'll have seen this last week. We've just completed an extensive combustion test program, really looking to understand how hydrogen can combust in a gas turbine and how we can take advantage of those differences in hydrogen combustion compared to kerosene. And you'll have seen over the last couple of years an awful lot of announcements around hybrid and all-electric propulsion systems, ranging from the very smallest urban air mobility and small aircraft all the way through to multi-megawatt high-voltage electric propulsion systems. And across the bottom, you see that we can't do this alone. Within the hydrogen program, we have around 100 partners, many of them in the UK, but also spread across Europe and globally. And we've been very fortunate to receive a lot of funding, both from Europe through things like Clean Aviation and through the ATI and Innovate UK within the UK. And those partnerships and commitments to funding are essential for us to do these kind of programs. So really, in conclusion, I think you can see Rolls-Royce's net zero strategy above my head. And the practical programs we're currently undertaking to make that strategy real really embody what I believe the tagline of this conference is. So thank you very much.
Thank you very much. Thank you very much, Adam, for this first part of the response, and we may come back to it in a moment. Moving now to Airbus with François Duclos. Welcome, François.
Thank you.
François, you have more than 28 years of experience in certification and airworthiness, both in the military and the civil domain. Before joining Airbus, you've been working a number of years in SAGEM, which is now part of Safran. And you have joined Airbus in 2001. Since then, you have been involved in certification, airworthiness of most of the major Airbus programs. And in 2020, you became executive expert for the Airbus Group, so all Airbus companies, for certification, rulemaking, and airworthiness. François, I read recently in the press a quote from your CEO, Guillaume Faury, and I quote, "We strongly believe that we will be ready by 2035 with a hydrogen airplane." So my question to you is can you confirm your boss' statement, and what steps is Airbus taking to go
Thank-
this direction.
Thank you very much, Rachel. I would say very simply, I'm very transparent. The boss say it, so it is true. The fact is, he said it, and indeed we are all aligned on this target, which is indeed very challenging. So, but just now I will answer precisely to this question, but to answer to this question, I would like to start a little bit backwards and remaining some principles which are the backbone of an aircraft manufacturer. You know, we are all speaking about carbon neutrality, zero emission, etc., which is, we agree, we are aligned. But I would like to recall some bases. It's the less polluting energy is the energy we do not use, we do not burn. So an aircraft manufacturer, before speaking about the type of energy or the type of propulsion, we consider the level of energy we'll have to use for a given mission. And now we have decades, and you spoke about well-established players, which is also the fruit of the experience, but we have decades of more efficient plane, which means less weight, less drag, better range. And to achieve this, by deduction, we have always targeted less emissions. So less emission is not new. And I would like also to remind the travels that we had, aerospatial and British aerospace in the years 1970s with the noise in the United States. Okay? And then the consequence of the oil price increase made that at the end, we wanted to burn less fuel, and thanks to Europe, but we have not waited on this to burn less fuel. Okay? Otherwise, because practically, less energy means more payload, more passengers, and at the end, Luc mentioned the need to travel is tickets which are cheaper for the passengers. So, in fact, it is a journey in which now we have a new constraint with a much higher pace, which is to be net zero carbon in 2035. So for us, it's an additional challenge. But hopefully, we are already used to face the challenges. Now, if I look now to the part of the question, which is the type of energy, alors it is true, I belong to Airbus. Airbus is considering with our engine partners, we are not designing gliders, that's true, to transport the passengers. We need propulsion. And we look to various types of energy, therefore propulsion, to make the mission which has been requested by EASA to consider to go from Seville, let's say the NH Collection Hotel, to Sumatra, going through Madrid, for example. So, but we took it seriously. It's not a joke, it's a practical case. First, I would like to say that to go from this hotel to Seville Airport, I would order a urban air mobility taxi. It's no more a dream. In the 20s, 40s, 17 years, it's going also quite well. With Airbus Group is also designing this kind of product with electrical propulsion, so a small step to the airport. Then if we go to Sumatra, from Seville to Sumatra to Madrid, we'll consider the more short-range plane, let's call it a regional, for which today we consider two aspects, either a full electrical, but the weight of the batteries is still a challenge. As mentioned, the weight, the gravity for an airplane, if we transport only batteries, we do not fulfill the missions. Or we can have also hydrogen planes, like our boss mentioned it, with this time liquid hydrogen propulsion, which is indeed something on which we are working at a great pace, with, of course, advantages. We have greener emissions, but also new risk. Hydrogen is more explosive than the fossil energy. And then Seville to Sumatra. But today, the best solution we have contemplated, we do not see in 17 years from now, but who knows, it continues to accelerate to be able to have a long range on the electrical or hydrogen, because you know also that technically hydrogen has less energetical capacity than fossil fuel. Therefore, we would need bigger volume, and therefore all the laws I have mentioned, if you transport only the hydrogen, you cannot transport passengers. So for this, SAF is indeed something we think would be suitable. Bon, SAF, for the one who, just to recall, SAF, I have to tell the truth, SAF still pollutes, but the carbon we emit is not coming from the ground. It has been first captured in the air, so we can speak about neutrality. And SAF would be the best fuel to go for long range. with some, this being said, some consideration to look to the system because the wear of the pumps, the valves, etc. And also the production of SAF is also a challenge. And I will finish by this. A figure today in Paris, Charles de Gaulle, the fuel consumed for the long-range mission is 6,000 tons per day. So to produce this kind of SAF coming from biomass, etc., we have all to structure the industrial chain. Today, SAF is only 0.5% of the fuel. Here we would need target 100%. So this is where we are. And because sometimes I don't want that you would think that I have hidden the question of our boss. It is true, we are going to 2035 for hydrogen liquid solution, and today the aircraft which is targeted is a regional one.
Thank you very much, François. And maybe to help you further on the regional portion of the journey, our next speaker is Phil Keenan from Hart Aerospace. Welcome, Phil. Phil, you are Head of Airworthiness and Certification at Hart Aerospace in Gothenburg, Sweden, and with this company since 2021. You have a total of over 20 years of experience in commercial aerospace product development, certification, and in-service support for previously Airbus in UK and France, as well as 2 years in Japan working for the Mitsubishi SpaceJet regional aircraft. Phil, can you tell us a bit more about the aircraft your company is trying to bring to the market? And maybe also more specifically, what are the challenges for a new entrant organization like Hart trying to design a new aircraft from clean sheet design?
Okay, so thank you, Raquel, and thanks to the panelists to be among previous colleagues and esteemed members of the industry. So yeah, we're at Hart Aerospace in Sweden. We started in 2019 a similar journey to what Jeremy illustrated. We started off before the pandemic, spun out of a research program looking at the Nordic market, fjord hopping, island hopping. We very much started in that ecosystem of the CS23. How do we penetrate a first product? How do we get something out there? Again, tagging straight onto Jeremy's perfect point earlier. The industry, the public, our families, our friends demand that we as an industry do the best we can in our lifetimes and in our careers to penetrate this climate challenge, and that's what we tagged onto and leapt into. So we started off demonstrating that electric propulsion works. Is there an efficiency gain there? And as you can see in the picture there of the team, we have a demonstrator where we tagged up some batteries and we controlled an electric motor, direct drive, and we turned the propeller. And we convinced ourselves, based on some data that we've gathered there, how we learn to control this. Electrification has viability to go forward with. And we've built progressively on that with demonstrators. What's the basic platform we want? What is the industry looking for? And we've done that quite tentatively, and considering the audience that we have here, very much hand in hand with EASA. So we started our DOA journey back in 2019, 2020, when the whole company, which was prior to me joining, I think 5 people went to Cologne for a first DOA meeting and presented what we think, here's a company based in PowerPoint and where we can propel ourselves to in some time. And you guys talked and we listened, and we learned a lot, and we put our heads together, and then we've kind of tried to coalesce on building an organization now that, as you can see there, in 3 years' time has grown from 5 people to 200. We have 30 countries represented. That has borne a lot of the diversity of the aerospace industry. But we've also been, and this is the key point for us, trying to capitalize on the electrification industry. So automotive industry has a lot of knowledge. What it doesn't obviously have is the knowledge of the aerospace industry. So we're trying to combine our mission and our journey along with what Francois and Alain have spoken about, the competencies and the capabilities in the European industry, and building on that. So we're trying to blend together the real novelties of the industry, electrification, batteries and motors, that we don't have so much of. And linked to what Alan said again, it's a fundamental bit there. We're focused very much on ConOps, trying to understand now as we've developed our product from full electric to a hybrid electric with a series turbo generator system, how does that work? How, where and when do we have all electric missions so that we commit and deliver on our environmental commitments? How, where, and when do we use that reserve hybrid? Again, as Francois has mentioned, batteries are heavy. The technology is ever maturing, and a move for us to a hybrid electric is a recognition of that. We know batteries aren't where we want them to be yet. Again, we have a platform there now that we're starting to develop and build up for the future, that we know we should then be able to scale both in size and the technology of the propulsion. But we're really trying to understand, as we grow our company, what's the concept of what it is we're building and what we want to put out to market and get it out there safely, building upon the fantastic legacy we have in Europe of aviation safety. And I'm proud to be part of that, and I know that the team are too, and how we then work with the regulators, with our airlines, with our operators in the infrastructure to have a great product that we can all be proud of.
Thank you very much, Phil, for this first part of response. Very interesting. So it shows that it is probably difficult to achieve a full electric product, because somewhere on your journey you decided to move from full electric to hybrid electric. I'm turning now to Dr. Sébastien Zeeman from Veridion. And I think Veridion is really trying the full electric model, and you will tell us a bit more. So Sébastien, you are co-founder and CTO of Veridion, which is a Munich-based startup. You are an aerospace engineer with 14 years of professional experience. You have been working previously with Airbus, where you've been involved in the City Airbus project with electric propulsion. And then you went into the automotive sector to get, I understand, a bit more insight and knowledge from the automotive industry on electric mobility. And in 2021, together with Ivor van der Tel, you co-founded Veridion to make battery electric regional air travel reality. So my question to you, is a full electric small transport airplane realistic, and with the battery technology that we have today? So can you tell us a bit more also about what you are trying to bring to market?
Absolutely. Thank you very much for the introduction. And I don't want to forget to really thank you for having us here, having me here. It's a pleasure, it's a great honor. And indeed, this is the question that probably everyone has as a first question: is it realistic? Can it be done? And it's really a pity that we lost you in this segment. We try and stay there. We develop a fully electric 9-seater for regional air travel. And to give you a number, I'm a very technical person. I try not to talk too many numbers, but this is a plane that is going to fly with the current technology that we have available. 400 kilometers of IFR range. That means 400 kilometers of travel, city to city, whereas all the reserves that we need are still in the batteries. And we can talk in more details about that. So effectively, the travel that we have as an example between Sevilla and Madrid would be possible electrically. So I just learned from Francois that Airbus is going to leave the segment to us. Thank you very much. We gladly take it.
This is not what I have said.
Very much the answer to the question, is it realistic, is diversity. Not all the flights and segments and ranges are realistic electrically. This is, I think, confirmed by everyone who is technically involved in the aviation industry. Long-haul flights will never be fully electric. Short-haul flights, however, can be electric. And there is, of course, a limit to that. So very much it depends on the technical the technical knobs you can turn. The technical knobs are effectively aerodynamic efficiency, energy density and efficiency of the powertrain, and lightweight design. The design space for that is not very huge, but it exists. It exists together with something that is also relevant for a market. And relevance for a market means passengers are going to pay for it. And this range, we believe, starts very much with 9 passengers and a range that is compatible with where passengers fly today. Many travels happen in the range below 1,000 and even below 500 kilometers. So there's a relevant market, and there is also relevant emissions. As we've heard before, regional air travel contributes to a large percentage of emissions. And for the narrow body and regional airplanes, it is 50%, more than 50% below 1,000 kilometers. So there is a problem to solve, really. And in Viridian, we have dedicated all the workforce and our brains to designing the most energy efficient aircraft. This is what it's all about. It has to be as energy efficient as it can be to get all the energy out of the battery that is available into range. And at the same time, it has to be a simple aircraft. It has to be something that is as simple and as conventional as it can be, because we also talk about certifiability and certification. And we want to be successful really soon. We want to have a product before the end of the decade. That means this combination has to work. And so, therefore, as you can see it on the slide, we focus on 2 main technologies. One of them is the battery, actually, the battery in the wing. The battery is in the wing and nowhere else to secure the whole space of the cabin for the payload. And the second thing is to have a novel engine architecture, as Alain has also talked about. And this should be the only 2 things we work on. And the rest of it is a conventional airplane operating from infrastructure that already exists. And we think that this is going to be the fastest way to certify something that is fully electric.
Thank you very much. I must say, I like very much the design of battery integration in the wing. It looks very innovative and interesting. So thank you for this first part of response. And moving now to Sébastien. Sébastien Dubois, you are representing here Clean Aviation, and you are Head of Program Development and Communications for the Clean Aviation Joint Undertaking. Prior to having this role, you had a number of positions in Clean Aviation's predecessor, which was the Clean Sky Joint Undertaking. And before that, you had spent 13 years working in French industry, in particular for the Thales Group, in various positions, including Head of Research and Innovation for Commercial Aircraft. Sébastien, the EU is investing a lot of public money together with industry in green technologies, and clean aviation is one of the main instruments for that. Could you tell us a bit more about your mission there, and how does clean aviation see the future aeronautical landscape?
Thank you very much, Rachel, and good afternoon, everyone. What will the future look like, and what is our mission? Before I jump on that question, let's just look backward, not so much about the Clean Sky 2 predecessor, because we are more or less in the last phase of this nice initiative, which was launched in 2014 to be run until this year, aiming at developing a broad range of capabilities and portfolio of technologies addressing 20 to 30% of emission reduction by 2030. And we are about, in fact, to deliver that results. Some of them have already been delivered, as mentioned by Adam, the UltraFan, which is a key asset for continuation and for implementation in clean aviation. We have others as well, like the Racer, which is the compound helicopters being capable to fly at 400 kilometers per hour. We will perform, in fact, this first flight test this year in November. We also have, in fact, another important work for what concerns the multifunctional fuselage demonstrator, with the aim, in fact, to reduce by 1 ton 8-meter long fuselage composite section. And we address a broad range of technologies serving, in fact, the different aircraft segments. This is in total 34 flagship demonstrators, more than 1,000 technologies, 5,000 scientists. We are very inclusive. We are addressing a wide range of capabilities, and this is something which is extremely valuable. Why I started with Clean Sky 2 is because we do not start from scratch, and this is a model which works well. But what now we are willing to implement is what we call transitioning from a technology development program to an impact-driven focus program. And this is what makes the difference if we want to accelerate our carbon neutral journey to 2050. This is in line with the Paris Agreement. This is in line with the long-term aspirational goals, which have been endorsed by ICAO last year. And this is the instruments for all stakeholders in Europe, being part of this decarbonization journey, to implement their roadmap. We are the EU leading research innovation program towards a sustainable carbon neutral aviation. And what you can see on that chart illustrated is what we are about. We are about, in fact, 4 billion euros of activities, which, by the way, it's very significant, but not enough. I will come back to that, how we can connect with other initiatives to transform the aviation sector. Just one single figure, if we want to be carbon neutral by 2050, there is more or less a level, there is 820 billion euros investment which is required across technologies, across ATM transformation, across sustainable aviation fuel, and others. So that's why I'm just saying that 4 billion is a lot, but when you look at the complete picture, this is something where we need to connect with others. We are about developing, in fact, aircraft concepts that are able, in fact, to enter the market first by 2035. 2035 is more or less the pivotal point. So if I rely on the statement made by Guillaume Faury about the hydrogen-powered aircraft, this is exactly that date which has been mentioned.
Yes.
And this is something important to bear in mind, because when talking about carbon neutral journey towards 2050, it means being capable to provide the market with solutions which are carbon neutral, or at least which are highly efficient, to being capable to ramp up the production, to deploy at a very fast pace. And in our scenario, if we want to address that objective, so first of all, we need to develop the technologies that will provide the future aircraft concept with an improved performance of 30% greenhouse gases reduction emission. This is one point. The second is to be able to provide the market with such solutions, and I will come back on that on the different scenario. And the third one is to be able to replace the existing fleet. In our scenario, you may consider this very challenging. It is very challenging. The replacement rate is 75% from 2035 to 2050. And this is on that condition that we'll be able to be carbon neutral by 2050. So this is in a nutshell our high-level objectives about clean aviation. How are we implementing this ambition? First of all, we are looking at two different aircraft segments, what we call the hybrid electric regional domain and what we call the short and the short-medium range. Why that two segments are addressed? Because if we look at the emissions for flying a distance below 4,000 kilometers, this is worth 55% of the emissions, considering, in fact, 2019 data. So that two segments are significantly contributing to the emission, and this is, in fact, what we are targeting. We are talking about hybrid electric regional aircraft, which is up to 100 seats and 1,000 nautical miles, with an average distance flown of 400 to 500 kilometers, which is not so far as compared to concepts which have been mentioned before. And we are talking about short and short-medium range, which is about up to 250 packs for a sizing mission of around 1,000 to 4,000 kilometers. And clean aviation is focusing on different types of propulsions. So either hydrogen-powered aircraft, either hybrid electric, or other, in fact, SAF-powered solutions. If we are capable to achieve that goal, it means that 30 to 35% of the expected gains by 2050 will be fulfilled by new technologies. So this is only 1/3 of the solution. The other part will be given by the ATM transformation, more or less 7 to 12%, depending on the scenario. And the other portion by the sustainable aviation fuel. Sustainable aviation fuel meaning either power to liquid or a biomass or also hydrogen. The reason why I mentioned at the start that 4 billion is not enough for clean aviation is because when referring, in fact, to the figures I mentioned before, we are at the center in Europe catalyzing, in fact, the different initiatives, but we need to connect that initiatives with the different instruments. One very good introduction given by Alain at the start is EASA. We have a close cooperation with EASA because if we want to be able to provide technologies that will enter the market by 2035, that technologies are to be viable, are to be mature, but have to be certifiable. Otherwise, we will not succeed. So this is our raison d'être of this partnership. Secondly, we work as well with other initiatives in Europe, like the Clean Hydrogen GU, because hydrogen is at the heart as well of our journey, because this is 1/3 of our pillar, and we are developing with them some common approaches. Common approaches for technologies, developing, in fact, the fuel cell, developing, in fact, the different distribution or the low NOx combustion systems. But we are also developing with them, in fact, what will be the infrastructure which is required to make this happen. Because talking about only technologies is not efficient. We need to make sure that that technologies will also get all the necessary infrastructure and the right fuel which is required to deploy. So that's why clean aviation is about two phases. It's about the first one, developing and maturing technologies. We have a first rendezvous in 2026 to define which technologies are candidates for continuation in that journey. And we have the other part of the program from 2026 onwards that will aim at integrating all that technologies together into actual environments. First of all, supporting the flight test that will demonstrate the feasibility of the multi-megawatt fuel cell propulsion system or the H2 direct burn concept, but also validating, in fact, the hybrid electric propulsion chain applied, in fact, to hybrid electric regional, and also looking at what we call the ultra-efficient short and short-medium range. This is implemented, that first phase, through 28 projects, which have been awarded, in fact, last year and this year, with a total funding volume of roughly 2 billion euros when we look at all that activity. And EASA is participating in every project in order to define, in fact, the future certification requirements, the future compliance means, the future digital framework which is required in order in 2026 to come with a certain number of draft requirements that will be used to further shape the content. I will conclude this short introduction by saying that clean aviation to date, this is about 300 participants, for which industry is about 50% of this involvement. 1/3 is geared towards research institutions and academia, and 15% in terms of participation is an SME. So we are an inclusive partnership. We are a partnership looking towards innovation, being focused on impact and working on future applications to bring to the market various solutions by 2035.
Thank you very much, Sébastien. You mentioned a few times the word certifiability. And yes, 2035 would mean also that the new products, etc., are certified. And that brings me to the question of what are the main certification challenges, which is also what are the main safety challenges for the design. And I think the answers will be different whether we talk about electric hybrid or hydrogen. So maybe first, for electric hybrid technologies and the battery and the high voltage considerations, what is it that will be the most difficult to mature? What are the biggest safety challenges? And how do you see us mastering them? And I'm turning to the electric companies here. Maybe Phil first?
Yeah, so it's part of the journey that we went through in the evolution of the 19 to the 30C, and the all-electric to the hybrid was an element of the readiness of CSE, so the engine specification, Part 33 in the US, the emergence and publishing of the special condition E19, very much then that the focus that we get is derived from the aircraft level objectives. So that's part of the challenge and the opportunity that we've also taken there. But as we've actually started to mature the architecture through the preliminary design phase, when we're discussing with suppliers, with Rolls and with various other people, it's looking then about the scalability of that, the individual unit certifiability of that. So is it TSOs for batteries? Is it CSE or something replacing it for electric motors, when turbo generators are turbos, where are the generators, which bit and boundaries do you draw within the architecture of the aircraft itself. So I think that's part of the big challenge that we need to come through, is that there's no one-size-fits-all solution for those certification challenges and gaps. We need a regulatory framework that, as Alan said, that fits where we innovate towards and as we scale, but also that fits the suppliers upon which we can't do this without. And we know that their business is then to have reusable units that they can sell to multiple people. So we have that real scalability and adaptability of the certification basis. But also then, for us, a big thing is the harmonization with other regulators around the world. So we have the benefit of being in Europe with you guys, and the world looks to EASA in that respect. But we need to make sure then that EASA and the FAA go on that same journey together. Because for us, we have a big number of orders already in the US, and our US customers obviously want us to be able to operate their aircraft there. So yeah, harmonization is a big thing for us going forward as well.
Yes, thanks. And we have actually a few FAA colleagues in the room, so I'm sure they will take note of this statement. And we are actually working hard, especially on electric hybrid propulsion system standards and requirements to see how we can converge on some critical aspects. Yeah. And Sebastian, maybe something to add on safety aspects of having so many batteries in the wing?
You nail it. The battery, in my view, is the main thing to focus on. And this is also why it was on the slide that we have prepared, because designing a battery that is has a high energy density, so both gravimetric energy density and volumetric energy density, not to be neglected, is key. Why? Because it has to be in the aircraft. So it needs, in our case, it's going to be in the wings, and it has to be safe at the same time. So we know the regulator's standpoint of EASA and FAA. The same is that nowadays that we deal with lithium-ion-based batteries, we have to anticipate that these batteries burn, which we call technically a thermal runaway event. This is something that we have to design towards, in a sense that it is contained in whatever the enclosure is, such that the aircraft itself doesn't get impacted by it. So literally speaking, the wing shouldn't burn. This, in my view, is the biggest challenge for electrification of aircraft. So very much the answer to it is a materials topic and also battery management system topic. Yeah. There is a solution to that. So I can, with a good confidence, say that the first steps we have made, finding materials that actually can deal with a thermal runaway, which is a big step into de-risking, and that comes very much back to what Alain had said before. This we need to do first, and also we need to validate it very, very early with the regulators to make sure that this is not going to be a stopping point, eventually only late when we do a TC application. I'm much more optimistic when it comes to the regulations, to be honest, because I believe, especially for electric conventional aircraft, the regulation framework is pretty much defined. The CS23 is existing. It includes electric aircraft. The CSE for the engines exists. The CSP for the propeller exists. The special condition E19 for the electrical propulsion system exists. And also, specifically for the batteries, we have what we need to a large extent. We have the DO311A. We have the means of compliance that we can derive from the VTOLs. I think this is there. And when, if you allow a challenge that these companies face, like Hard Aerospace, Aura Aero, and ours as well, lies also in the nature of the organization itself. Yeah. So startup. We are different than other companies are. One of the biggest challenges for us is to survive. And that means we every day face the challenge to get new funding, to build on different schemes than what Sebastian had said before, at least complementary to them. This nature of companies involving them in the ecosystem of aviation, which in the last decades has grown much differently, is, I think, one of the biggest challenges.
Thank you very much. Fascinating response. And moving to the safety challenges without transition of hydrogen, maybe Adam, do you want to say something about that? Hydrogen seems to burn very quickly, easily, and without showing. No?
Yeah, absolutely. Yeah, from an engine manufacturer's perspective, I think hydrogen's the dream fuel. You can take a lot of benefit from the way hydrogen burns compared to kerosene. I guess the approach we're taking is to approach hydrogen with caution and with data and not with fear. There's a lot of people instantly go from hydrogen to explosions, and they talk about all of these things that can happen. But the reality is hydrogen is used in great abundance every day in the world, and particularly in continental Europe. There are pipelines that move hydrogen safely every day. And we can take a lot of confidence and some initial understanding from how other industries have safely used hydrogen both as a gas and as a cryogenic liquid. I guess where the challenge comes from aerospace and when, as engineers, we start to get excited is the basis of safety for these industrial applications isn't applicable to aerospace. You look at a hydrogen plant and everything is separated by big different distances, and everything is segregated from everything else. That would be impossible to do under the cowl of an engine bay or in the airframe of an aircraft. So it's really starting to understand how do we take that basis of safety that we have today and look at how we do fire, ventilation, drainage, and explosion kind of principles and philosophies in a different way. And that becomes really interesting, and that's where we start the technology journey to say, well, how do we make leak-proof systems? How do we understand, leak detection inside the nacelle of an engine and be able to detect, we're now leaked hydrogen? What are the safety systems that we need to put in place to allow us to still have the same level of availability and robustness in the power plant? I don't think many people realize just how many things can go wrong on an aircraft before you actually get anywhere near to an unsafe condition. And it's how we bring that same philosophy to these hydrogen systems is going to be a real key part of the next few years.
Yeah, thank you very much.
Yes, I would like to compliment on hydrogen. So I know I am speaking to EASA, but I would like to recall what is certification, because you asked the question, what are the certification challenges? For us, an aircraft manufacturer, certification are the activities which are conducted, to show compliance of a product with the applicable requirements, and thus allowing to achieve, ICAO speak about the minimum level of safety, let's say the acceptable level of safety. So there are two aspects, the requirements and the compliance. I think that we should take this introduction of hydrogen as an opportunity to simplify, and not to add additional complexity on an existing framework which is already very rich. I think that at aircraft level, we do not miss a lot when we introduce hydrogen. For us, it's new risk, but the way to mitigate, but the way to tackle the risk is already well defined. And the second thing I see is, for us, the real challenge will be in the means of compliance. Because as said by Alain Leroy at the beginning, we lack experience. Even as rightly said by Adam, there are already hydrogen used. We could mention also the rockets with liquid hydrogen. We will have to find a commensurate way, pragmatic way with the aviation authority to say, okay, today we do not have enough experience, we cannot reuse in-service experience, but to show compliance, we must not do something which will kill the business. And this is something we have to work, because today we focus a lot on requirements, which is good, knowing that we have already a lot, but we must not forget the means of compliance. This is for us a challenge.
Yes, thanks. And I think we are aware that it was mentioned that for electric architectures, we may have the vast bulk of what is needed in terms of requirements and standards. We may not be there completely yet for hydrogen. And so that would be a challenge also for the regulator. Maybe we should have a look at the Slido questions, if there are some already. So, and the first question is not at all on what we discussed, is on SAF. The key issue is the large-scale production of SAF. How can that be achieved if at all? It's not, strictly speaking, in the scope of but we can try to answer it. I have a sub-question on SAF, so whoever is taking that one could maybe complement. SAF is not necessarily equivalent to SAF, and depending on what we are talking about, the climate impact or reduction impact can be very different. So I would also be interested in knowing a bit more on that. Which types of SAF should we be really looking at for maximizing reduction of climate impact, and how are we going to manage the production? So I think I'm turning to Rolls as natural speaker on that.
Okay. Yeah, it was a little hard to follow because the screen kept changing. But I guess from our view, sustainable aviation fuel falls into really two categories. Kind of the bio-derived SAF, often we're called heifer SAF, which is largely certainly what we're using today and what a lot of the demonstrations are looking at. But really in the future, I think what we need to move towards is e-fuels or synthetic fuels, where we've taken maybe captured carbon and we combine that with hydrogen through things like the Fischer-Tropsch process. And you're absolutely right. It's the industrial challenge of ramping up to that level of fuel consumption is really key. I guess as an engine manufacturer, that isn't something that we can do ourselves. But what we are trying to do is build alliances like the Hydrogen in Aviation Alliance you may have seen in the last couple of weeks, which is around trying to bring industry a voice to go and lobby governments and policymakers to make sure that the right investments are being made in the fuels at the right time, and trying to give our view on what sort of volume of fuel might we need when, such that when these fantastic technologies are available, the rest of the infrastructure is there to do them.
Thanks. And the next question is in the same vein, interesting also. Has EASA carried out a holistic assessment about the impact of fossil fuel emissions versus green technologies, considering that not all hydrogen being produced is green and that the production of lithium batteries has a non-negligible environmental impact? So that's back to the question of how green the new technologies are, and we really need a full life cycle assessment.
That's it.
Of it, and it's also a question of who should be doing this whole life cycle assessment. So under the Refuel EU regulation, the Commission is already regulating to some extent the complete impact when looking at alternative fuels. But when we look at new technologies, I think I will be turning to Sébastien to ask about under clean aviation, how do you plan to measure the overall impact of what is developed and the climate efficiency of the new technologies?
In fact, you are raising a very good question, and there are two angles to look at. One is about, and this is in relation with that question, what is the well-to-tank efficiency of the systems? In other words, when talking about SAF, we take for granted that someone will produce hydrogen, someone will capture the CO2, and someone will come to the market with some PTL. This is quite simple, and then will be all carbon neutral. But one very underlying assumption behind is that we need to make sure that we are capable to produce all that elements in a green manner, meaning with solar energy, with wind energy, and this is not yet taken for granted. When you look at the complete chain, there are studies which are different, but we are talking about several petawatts of electricity, which means already more than what we can produce in Europe through, in fact, in a green way. So this is one challenge. The second, when talking about sustainable aviation fuel, we sometimes do not forget that as part of the system, the intermediate step is hydrogen should be made available. And hydrogen is the first point. And when you look at, in fact, the amount of energy required between producing, in fact, liquid hydrogen versus SAF, there are some studies which demonstrate that you need 2-3 times more energy to produce sustainable aviation fuel than to produce hydrogen. So that's why hydrogen is an important element of that journey. And the last but not the least, when we look, in fact, at our transition toward carbon neutral aviation, the cost is a very important dimension. We need to make sure that we'll be capable to produce all that fuels at the right cost, which means, in fact, developing technologies which are more efficient makes a lot of sense, because it means that we'll be able to compensate that extra cost. And this is, in a nutshell, in fact, what is at stake. Being efficient in producing, in fact, that energy, and being capable to scale up that energy, that SAF in right quantity, which is about, in fact, EU regulation.
Turning to the electric and electric hybrid companies, so how are you looking at the whole life cycle aspect of the aircraft you will manufacture? Maybe Sebastian first.
Yeah, thank you very much for the question. I totally embrace it, because I also deeply believe, like personally, that you cannot just look at the aircraft or the vehicle itself, but you need to look at it all, really from the energy generation until basically scrapping the aircraft in the very end, or recycling, hopefully much of it. So what is true, and I read it out of that question already, is that of course electric aircraft have consume resources as well to produce batteries. So I think there is something that, I would like to express personally. Is there such a thing like emission-free mobility?
No.
No. There is not even emission-free anything. Even our thinking or our browsing in the internet, or this is all consuming emissions. So, of course, lithium-ion battery production consumes resources as well. When it comes to the life cycle of batteries as such, I think the big opportunity we have. I think if I ask you the question into the audience, who doesn't use batteries at home? No one is going to raise the hands, because obviously we use them. They can be recharged multiple times. So as opposed to any fossil fuels we use, if we like it or not, and I'm using them as well, they just vanish. We can recharge the batteries hundreds of times, and even after that, out of the aircraft, they are going to have a second life. They are maybe at a state of health of 80% or 85%, where we consider them operationally no longer viable for how we make money in the aviation, but they are still there. They are still operational. We can use them for local energy storage, for example. Yeah. Finally, they are going to be recycled. Recycling of batteries today means that lithium can be recovered to a percentage of 65%. The other elements, like copper and nickel, for example, cobalt, they can be recycled to a percentage of 90%. So this is something, and I fully agree that this has to be carried out on a holistic level, and to compare it and to say not only what is possible technically, but also what makes sense market-wise, but also what makes sense really resources and overall energy-wise needs to put into a global context.
Yeah, thanks a lot. So recycling is a key word, and I was actually looking into electric cars, and I read somewhere that when you buy an electric car, you think you are doing something very environmentally friendly, but before being built, the car has already used up 40% of the carbon credit a traditional car would use overall its life. So, yeah, there is no zero emission energy or power production. Thanks a lot. Phil, you want to add something on?
Expanding really on what Sebastian said, it's that point around the reuse. We know in order to make the batteries certifiable and safe for the aerospace application, they'll take particular form factors to withstand the operating environment and to withstand the risks of crashworthiness. So first of all, what's the opportunity to immediately reuse those once they've taken an end-of-life cycle from the aerospace application? And then how do I break that down into the next stage to be able to reuse it with a reform? How do I reuse that or recycle that in some secondary form? And that's part of what we're in that joint definition phase with our battery supplier at the moment, and discussing and using sustainability requirements in the European system to try and help drive the design in the right way. It's reuse, reforming, and then recycling, and ultimately down right back to the end of life cycle.
Okay, good. Thanks for this. And back to hydrogen, and there is also a life cycle aspect, of course, of burning hydrogen, of producing hydrogen. But when it comes to burning hydrogen, it's also not fully clear to me how green burning hydrogen actually is, and there is a lot of debate around the non-CO2 effects of it. So that's a question to Airbus and Rolls-Royce. How do you see the overall climate impact reduction and the non-CO2 effects of burning hydrogen?
Let's go first.
If you want. But I would say Airbus is not only hydrogen, even if there was a question of our CEO at the beginning of this panel. It is true that with any kind of energy, you have always to look at the benefit and the counterpart. And today we see, and that's true, a lot of benefit associated to hydrogen, because when you separate hydrogen, when you combine hydrogen with oxygen, you obtain water, H2O.
But maybe contrails also.
And this is the point. So you can have, occur with hydrogen, you have no CO2 exception made of how we'll produce it, and rightly said by Sébastien, we need today energy to produce hydrogen, and we have to commit of what is green energy to produce hydrogen. France would like to use nuclear, which is not considered as green by other countries. We can use solar, we can use wind, but about the recycling. So my message is really, and as an aircraft manufacturer, we have to look to consider all benefit and counterparts. And what is in the perimeter of an aircraft manufacturer, indeed, is the storage, the efficiency of the plane. This is very important to have mentioned it. It has been mentioned by also, and is rightly tackled by Clean Aviation Program. They target 30% less energy. And then we have what remains after the combustion, which for hydrogen is the contrails. Well, hopefully there will be no carbon, there will be water, and today we are studying, but we hope to have greener contrails than with fuel energy. This is where, and now if you ask what are the results, but just today, Airbus, we are flying, and we have, there is no, I would say, we can dream, and then the reality is today we'll equip an A380 as a flight test bench with a fuel hydrogen engine, direct to burn, and then we'll measure. And I said at the beginning, we are used to measure emissions for decades.
Yes.
And then we'll come back to EASA and to the European institution.
Yeah, thanks. Adam, anything?
Yeah, and I think from a Rolls-Royce perspective, very similar. I think we're always very careful to talk about net zero carbon and not zero emissions, because I think you can easily mislead people. I think the science around the non-CO2 effects is really interesting, and there are so many things that we just don't know yet. We know hydrogen combustion releases more water, but what is the configuration of that water vapor when you no longer have soot in your exhaust, and therefore you've removed one of the nucleation points for water droplets? Nobody understands that science today, and I think it's programs like ours and the Zero E program that Airbus are doing will really help answer some of those questions. The combustion test program we've just done, it was, I personally believe, the most comprehensive aerospace combustion test program ever done, exactly to go and understand, well, what is the NOx emissions from hydrogen combustion? Is it as scary as some people think, and it's going to be orders of magnitude worse than kerosene, or is it something that we can control? And NOx has been something we've always had to manage. How you manage the temperature in your combustor, how you mix the airflow from your compressor with the air that you're burning has been a challenge that we've had ever since the gas turbine was invented. And we have an awful lot of ideas about how we would manage that in the future.
Thanks. One more question maybe to Sébastien before going to the Slido. So will Clean Aviation look into the non-CO2 effects of the new technology?
It's a very good question and a very controversial question, I would say, in a sense that Clean Aviation regulation is greenhouse gases. It's not CO2, it's greenhouse gases. And greenhouse gases stands for CO2 plus non-CO2. Currently, non-CO2, whether it's right or wrong, I don't want to enter the debate, is sometimes estimated to 2/3 of the global warming. And 2/3 of the global warming linked to what? Linked mainly to contrails. This is not my opinion, this is what is currently. That's why the European Commission has decided, first of all, in the regulation of clean aviation, not to mention any more CO2, but greenhouse gases. Secondly, to propose, in fact, an obligation of reporting from 25 onwards that EASA will be in charge as well to assess what they call the monitoring, reporting, and verification scheme. And now the key question is that what is going to be reported? Will it be about NOx, as said by Adam? So far, this is not really in scope, but this is an important element. Do we have to regulate the NOx? But the NOx have some cooling effects as well, so it could be considered as being positive. We have a clear regulation, takeoff and landing on ground, but in flight there is nothing. For what concerns the contrails, there were a very interesting question. Hydrogen, will hydrogen produce contrails? Yes, if this is direct burn, question mark, if this is a fuel cell. Because this is fuel cell, it can be regional. If this is regional, this is at the low altitude. Or there are also other techniques to mitigate that. So this is a very difficult question. And for what concerns the understanding of that phenomena, we need as well to capture data. But capturing data is not an easy route. You need to capture, in fact, the temperature, the conditions, the trajectory. Then you need to report, and then you need to post-process. So it's the start of that discussion. So yes, clean aviation is focused on that. We need to define the right metrics. What are we talking about? And one, having the right understanding of the different species, we need to define some targets. But I fear that it will take time because of science is not evolving as rapidly as such. If we want to really understand and to have the right decision-making tools to define the future design.
Thanks a lot. I think that was a very interesting discussion, and we have achieved over time CO2 certification of aircraft. We have that now in place in terms of requirements, and probably we will move towards a non-CO2 also equivalent process in the future. One Slido question to finish. Proposed designs for electric airplanes are limited by what the current technologies can deliver. Weight of the batteries in excess of 4 propellers. When do the experts estimate that technology will allow to design a comparable product to those that are flying today on fossil fuels? I guess that could be a concluding question also for the panel. When do you see a green aircraft being available? And the answer, of course, may depend on the size and the technology. That would be my last question to the panelists with a subsidiary question. What is it that you would need from EASA in the short term, in the next 1 year's time, as a priority kind of support? François?
Yes. I would say that something very basic. You know, in a company, the salary of the employees are paid by the product we sell at the end of the month. So what we expect from EASA and from Europe also is to keep the right to operate for the operator with the current product, which, by the way, are much polluting than the previous one. It's a new generation of NEO. We have 30% less. Until we have the time, the facilities, you mentioned rightly, the knowledges, the volunteer, the decision gates to choose for the right solution and not to step back 5 years after saying, it was not the good one. Until we have this time to make the good product, which, by the way, will be a game changer. But the game changer, we must not be a loser, because we are not in a, there is a worldwide competition where Europe is there, and we want to continue to be there. So my point is we have to manage the transition, allowing us to go from, it will not be from one day to the other. We have to prepare this transition, making the right choices. Today I mentioned each energy has pros and cons, and rightly said by Sébastien, we need to come to the right decision gates, which will allow the safe product. This will take for sure years, even if we have some very short-term initiatives which demonstrate this. So I cannot tell you it will be 5 years, 10 years, 15 years. Just to remain to develop a brand new plane, large transporters plane, it's 10 years. And we have to develop the good one. Otherwise, we die. That's it.
Thank you very much, François. And I think actually these were quite nice concluding words. And as we are running short of time also, I apologize for the remaining panelists, but I will propose to close the panel now. And thank you very, very much for the fascinating discussion. Thanks.
Thank you, everybody.
Thank you.
Very good.
Thank you very much, Rochelle, and all the panelists. Thank you. We're going to have a coffee break in just a moment, but just before we do that, just a couple of things. Tomorrow we have a study visit that is taking place in the afternoon, which is optional, and you had the possibility to register for that when you first signed up. If you're not absolutely certain whether you signed up for it or whether you're going to go, can you please get in touch with Anna? Anna, are you there at the back somewhere? Anna's there, sorry. So stand up, please. So Anna Galasso is here. She's the person who you can contact or speak to or send an email to events, and then we can just get the numbers straight. The thing is, we have a maximum of 130 places, so we need to make sure that we haven't got places allocated to people who aren't going, and then we're turning down other people. So just for that. Secondly, we need the speakers, please, to be back at no later than 10:02. And the coffee break will end at 1600 and we will start then. So please be back in the room at 1600 so we can also finish on time. Thank you very much. Coffee's just outside. Thank you, front row.
"20 years is a very long time in a sectorized dynamic as aviation. In 20 years, there have been a number of challenges, failures, successes, tragedies. But what has always amazed me is our capacity to adapt ourselves to the new challenges and to the new world.
The sense of achievement and the team spirit were great, and the